We'll see chaining. In chaining, what we are going to do is we are going to maintain linked list on every array location. So we'll see how to maintain this linked list with an example. So I am using a hash function h of k equal to h of k is a hash function equal to k percentile 13, right? Let's see example 13. How I insert in chaining model is like same thing. I apply hash function, it will give the memory location or array location where it would go. So k percentile 13 is 0, right? So 13 percentile 13 is 0, it goes here. So here we create a node, new node, and we write 13. So we know linked list, right? Then 13 is done. After that, let's say 27 comes, we try to apply this hash function 27 percentile 13, which is nothing but 1, right? Then we'll try to create a linked list at 1 in that way. This can be imagined as array of linked lists, correct? Now here we write 27. After that, what happens? 43 comes. If 43 comes, then what we do? Again we apply this 43 percentile 13. It would be 13 3 is 39, 4. So this will go here. 43, then 65. So 65 percentile 13 is 0. Then what we do? We have to insert here in the linked list of 0. But already 13 is there. There are two options. You insert at the end, otherwise insert at the start. Which one would be good? Because we know that in linked list, so inserting in front will be definitely less time consuming, right? It's an order of one operation. So I insert in front. I create a node like this. I write 65, I link 65 to 13 like this, and I link here to here. Because of that, this would become 65 first, after that 13. So next 23. So 13, once a 13, then remainder is 10, right? So with 23. So for that I will go to 10th box. I create a node like this. So this is a way linking will be done. 37, 13 to the 26, then remainder is 11. So we'll try to insert here. Correct? After that 39. 39 is again divisible, so remainder is 0. Then we will go here. Here already two nodes are there. We have to write 0, create a new node, link here to here and here to here. Okay. So because of that, it would become 0 first, after that something and something, we know that, right? So this will be the idea about chaining. So what's the problem with chaining is, so sometimes what happens in the worst case, you might have only one chain of n nodes. Example, you are inserting n nodes. What if everyone goes to, that means everyone's hash function same, then you will form a linked list of n nodes in one bucket, I can say. This is, let's say, call as bucket. So what to do then? What is the time complexity of searching? Time complexity of searching sometimes, now example, you are searching for an element in it, and that element especially here, then you have to come here and you have to search all over here. And don't say, sir, I have to search this also. No, because whenever example you are searching for an element, we apply hash function that will give directly index of the bucket. Once we come to bucket, we have to traverse the linked list. It takes order of n time. So that is the worst case scenario of chaining, correct? But generally, so if I assume uniform hashing, the keyword I am using is uniform hashing. What is uniform hashing is, your hash function is such a way that so every bucket is going to take values equally, otherwise there is a probability that an element can go anywhere. If that is the case, why it will be formed, right? Try to understand. Really your hash function is uniform, this case never arises, but in that is what theory. In theory we assume like that, but in the real world anything can happen. Whatever you assume, something else will happen, and still you can have this kind of chain in the worst case, right? So my assumption, uniform hashing, will just give some what a reason or logic, otherwise I can say some convincing argument to say that this won't happen. Otherwise it happens very rarely, but in the worst case still it can happen, right? Yes. So if it really happens, the time complexity will be order of n for search. So insertion example, you want to insert, insertion always order of 1. We'll see the time complexity is search. What was the search time complexity? Order of n. What is the insertion time complexity? Insertion is always order of 1 because I will go to the corresponding bucket based on my value. Then after that I just do insert in front of the linked list. I insert here, so whatever the big linked list it is doesn't matter for me, right? Deletion. So deletion involves search, so deletion takes order of n, correct? So this is about chaining model. But let's use some mathematics here, uniform hashing. If I assume uniform hashing, we can prove that average here, what is important is average length of the linked list. So what is the average length of the linked list? I am not using that rigorous probability at this moment to prove that average linked list is n by m, but I just give some intuition behind why average linked list length is n by m, where n is total number of elements you are inserting, m is the total number of buckets you have. Okay, so m is total number of buckets, example here 13, and you are inserting n numbers. So average bucket size, obviously, so the intuition I will tell you, you have 100 numbers, there are 10 buckets. If every number has a uniform distribution, otherwise every number is equally likely going to every position, then how many I can say how many integers will go to a particular bucket on average? Definitely 100 by 10, correct? You have 10 buckets, every bucket takes equally, then it will become 100 by 10. Here 100 is n and buckets, number of buckets m, n by m. That's why, so of course there is a rigorous mathematical proof for it. I am not discussing that. So average linked length size, okay, here average list size is in this problem in chaining is just n by m, where n is total number of elements you are inserting input, m is nothing but total number of buckets you have taken. Now what we do is we carefully plan our m. So what is our target is really you want to achieve search time complexity. Let's for time being we assume that, let's take average case. In the average case what happens, search will become definitely depends on the length of the linked list, right? If length of the linked list on average is n by m, then search will become order of n by m, right? So insertion takes order of 1, however deletion takes order of n by m. Now carefully if you plan m such a way that n equal to m, otherwise m is in your hands, right? So try to guess number of integers you are going to store. If you can guess properly, so that we can fix your m size which is equal to order of n. If you can fix like this, m equal to order of n, then this will become m is order of n. Then what happens, overall will become order of 1, isn't it? That means m is, let's say n, then n gets cancelled, you get order of 1. Here also if m is almost equal to n, it would become order of 1. That is what I would like to say finally about chaining. So you understand chaining, right? And one important property is on average the bucket size, the linked list length is n by m on average, but in the worst case it will be definitely n. So on average case the time complexity of search and insertion and deletion is order of 1, right? Sorry, order of n by m, order of n by m for search and deletion, for insertion is order of 1. But if you somehow carefully plan your m so that if m is order of n, then everything would become order of 1. This is a story about chaining. In GATE exam, they ask only one kind of question here. That is, they give a problem, some number of buckets, and they give some integers, and they ask, if following keys are inserted into this array, then how many collisions occur? Second one, what is the particular bucket 8 size? That means number of nodes in the linked list of 8, number of nodes in the linked list of 7. This kind of question they ask. That's it.